Solving a system of linear equations by elimination. A system of equations consists of two or more equations. For instance, x plus 4y equals 10 and 2x minus y equals 2 is a system of equations. The solution to this system is a value for x and y that satisfies both. X equals 2 and y equals 2 satisfies both.
In this lesson, you'll be learning how to solve a system of equations by the elimination method. Your first step is to create a zero pair with one of the variables, then combine like terms, and finally solve for the variables. So in order to solve a system of equations by elimination, our first step with a system such as this, to solve with elimination, we want to create a zero pair with one of the variables. In this example, we actually have a zero pair all ready to go. Negative 3y and positive 3y are a zero pair because when I combine negative 3y and positive 3y, it equals 0. So, let's combine this equation, our second step. Combine means to add the equations together. 4x and 2x, I can combine those like terms, 6x. Negative 3y and positive 3y combine together to be 0, thus eliminating the y variable. And finally, negative 4 and 34 combined equals 30. Our next step, we want to solve for the variables. So, x. If we divide both sides by 6, that leaves us with x equals 5. If x equals 5, what we're suggesting is that 5 is the value for x that will work in both equations. Let's find out the corresponding y value. To do that, we plug in 5 for x in one of the equations. So, 2 times x, or 5, plus 3y equals 34. 10 plus 3y equals 34. Subtract 10 from both sides to keep our equation balanced. 3y equals 24. Divide both sides by 3, y equals 8. So what we're suggesting that the solution to both of these equations is x equals 5 and y equals 8. We can write it as an ordered pair. X is 5, y is 8. You'll notice when you solve a system of equations using elimination, you have to write the two equations in standard form. And by that I mean the x term, the y term, the constant, on the other side the equal sign. That way when you combine like terms it makes it easier because you've got your like terms in columns. So in this case, we want to create a zero pair. That's our first step. In this case, there isn't a zero pair in one of these variables. So we're going to have to multiply the two equations by a term in order to create a zero pair. Now remember, as long as you multiply the entire equation, both sides, by the same number, you'll be creating equivalent equations, so it's acceptable. So in this case, the first one, let's say we multiplied this first equation by 5. And then we multiplied the second equation by 2. Let's see what happens. We're trying to create a zero pair here. Did we create a zero pair? We have to multiply. I draw arrows here to show this will now be an equivalent equation to that. 5 times negative 2x, negative 10x. 5 times positive 3y, positive 15y. And finally, 5 times negative 1 is negative 5. 2 times 5x is 10x. 2 times 2y is positive 4y. And 2 times 12 is 24. Now we have a zero pair magically right here in our x term. So we're going to combine these two equations together. Combine means to add. That's a zero pair. How about 15y and 14y? Combine them, you get 19y. And negative 5 and 24 is equal to 19. Next step, solve for the variables. Last step. Let's get this 19 moved to the other side. So divide both sides by 19 to get y by itself. Y equals 19 divided by 19, which is 1. Now we're suggesting that y equals 1. If y is 1 in both of these equations, we should find an x value that will make both equations work. So let's plug in y equals 1 into the first equation. Negative 2x plus 3 times y, which is 1, equals negative 1. Negative 2x plus 3 equals negative 1. Let's subtract 3 from both sides. Negative 2x equals negative 4. Divide by negative 2. X equals 2. So, if x is 2 and y is 1, that will work in both of these equations. We can write it as an ordered pair. Let's look at another example of a system of equations we'd like to solve using elimination. So the first step is to create a zero pair with one of the variables. We don't have a zero pair in this equation, but we can create one. Let's create one. Seems very close right here. We could create a zero pair by multiplying that first equation by negative 3. This first equation becomes positive 3x, negative 3 times 2y is negative 6y, and negative 3 times 10 is negative 30. This equation we don't need to multiply by anything. We can just keep it as is, because we have a zero pair in our x terms. Let's combine our like terms together. Negative 3x and positive 3x are a zero pair that eliminates the x value. Now we've got another zero pair. Negative 6y plus 6y, that equals 0. Negative 30 and negative 6 together are negative 36. If you get to the point in your solving and you get 0 equals negative 36, we know that's not true. If we get something like this, something that's not true, an equation that is not true, that means there is no value for x and y that will work in this system of equations. And so we say, no solution. Typically in a system of equations word problem, you're going to have two equations that represent different things. In this case, and usually with money, we have an equation that represents the money and another equation that represents the quantity. So, the mathletes sell a total of 101 tickets to their Math Olympics. A student ticket is $1 and an adult ticket is $2.50. Total ticket sales are $164. How many student tickets were sold? Well, the first equation, let's call our quantity equation, depending on how many tickets there are. Well, if we call S is equivalent to the number of student tickets sold, and A is the number of adult tickets sold, we can write an equation saying that S plus A equals 101 tickets total. Now let's figure out the money equation. We know that a student ticket is $1. So $1 per student ticket plus $2.50 per adult ticket. If we add these two amounts together, we should find the total from ticket sales for the event, Math Olympics. You'll notice we've got our like terms in columns, so it's going to be very simple to use elimination in this case. And we almost have a zero pair lined up, but we don't. We have to multiply one of these equations, so let's multiply this one by -1. This becomes negative 1s plus, minus, there we go, minus 1a equals negative 101. I distributed this -1 to each of these terms. And down below I've got 1s plus 2.5a equals 164. Let's combine our like terms. Negative 1s and positive 1s is a zero pair that eliminates the s variable. Negative 1a plus 2.5a is 1.5a. Negative 101 plus 164 is 63. Next, divide both sides by 1.5. A equals 63 divided by 1.5. $42. So we believe we sold $63 divided by 1.5 is equal to 42. So we think we've sold 42 adult tickets. How many student tickets have we sold? Come back to your original equation. If S plus A, or 42, is equal to 101, subtract 42 from both sides to solve for the variable S, you get, what is that, 59. So 59 student tickets, 42 adult tickets, works in both equations. We're good to go.